Hello everyone, let's discuss this problem. How would you convert the following compounds to aromatic compounds? So this is a non-aromatic compound and we have to convert it to aromatic. So if you see, this molecule can be converted to cyclopentadienyl anion, which is an aromatic, but we need to remove acidic hydrogen. This is actually acidic hydrogen and we need to remove it. For that we need a strong base. We can use sodium hydride, okay, or you can take butyl lithium. Any one of these can work here, butyl lithium or sodium hydride. This H minus will abstract this acidic hydrogen and we will be getting this aromatic species. So it has total of 6 pi electron, aromatic, and it is conjugation throughout the ring. Let's move to this one. This can also be converted into aromatic compound if you're able to make carbocation to this carbon. Okay, so in that case we'll treat with sulfuric acid. Sulfuric acid will protonate this alcohol by giving H plus. Okay, and it will be converted into good leaving group that will be converted into actually water, which will leave and it will generate carbocation and that will be this one, which is again a 6 pi electron and it is aromatic species. Now let's see the third one. We can use here silver nitrate, aqueous silver nitrate, and you know that it has great affinity towards chloride ion, so it will remove it and will form AgCl precipitate and this carbocation. This again 2 pi electron and it is aromatic. In this case this can be converted into pyrrole. Just we have to abstract this acidic hydrogen, so we can use a strong base here. We can just use a strong base and that strong base will be able to abstract this acidic hydrogen, right? So we can use like again C4H9 lithium or NaH or even NH2 minus, and it will be converted into this aromatic species, that is pyrrole, which is 6 pi electron aromatic. Let's move to the next one, this one. This is having 8 pi electron, but if you remove this acidic hydrogen, this one, that is acidic hydrogen, for that also we can take a base like butyl lithium or sodium hydride. It will take this acidic hydrogen and you will be getting aromatic species which have total of 10 pi electron. It will get negative charge basically. In this case we can abstract this Cl minus by using again same AgNO3. Okay, and it will form AgCl precipitate and it will form this compound basically, you can see. Okay, and this is aromatic. There will be conjugation like this and it will be further converted into this one. Yeah, now this is aromatic. It has total of 6 pi electron. So these are the following ways by which these compounds can be converted into aromatic compounds. Thank you.